it kind of sets up a channel from the server to your browser. And now whenever there's an event, the server can now push events down this pipe. But this is one way. So you can't talk back up the pipe. Typically not a big deal because you can still make an HTTP request. And then the other problem, and I guess it's a problem when you're, I guess, in probably bigger companies, is that this doesn't work for IE, and I believe Edge doesn't support it either. So it's great, but has limitations. And lastly, or at least currently, I guess the most widely used technology for real-time is WebSockets. And how that works is that it's still an HTTP request, but this HTTP request is asking the server to whether or not it can upgrade your connection up to a WebSocket connection. And the server says yes. And now you have this bidirectional pipe between you and the server that not only can the server push information down to you, but you can push information up to the server. So that's WebSockets. Those are the three kind of main real-time technologies these days when you're dealing with real-time on the web. So you can certainly go and just like find the right calls and actually make these WebSocket connections yourself, or server sent event connections yourself, or implement long polling yourself. But there's a much easier way, and that's why we have these real-time web frameworks. So one of the first kind of successful ones that came out was Socket.io in Node world. Actually, when I first picked up Node, it was specifically because I wanted to use Socket.io to do some real-time web. And then about a year later, SignalR came out on the Asp.Net stack. So we had the same kind of capability as well. So what Socket.io and SignalR and these other real-time web frameworks do is that it kind of provides a layer of abstraction over the underlying transport. So you don't have to worry about it. You can just add the library, and then you get real-time on your application. And then behind the scenes, on every connection, is actually figuring out the best type of connection that you can have with the client. So these days, with SignalR and Socket.io, it will prefer WebSockets, but it will fall back to server-sent events and long polling. And I think in the case of Socket.io, I think it does other things as well, until it finds one that actually works. So like I was saying, single abstraction over the transport. So you don't have to worry about it. You'll just create a SignalR connection, and then behind the scenes, the library deals with everything for you. And also provides you bidirectional communication. So even on technologies like server-sent events and long polling, where you don't have that channel back up to the server, it basically just behind the scenes implements HTTP. So even though your client is making a call that appears like it's using the same pipe to talk to the server, if it's not connected using WebSockets, it'll basically use a different way to talk to it. So again, it patches over some of these rough spots for you, so you don't have to worry about it. And on top of that, you actually don't have to even worry about individual connections when you're programming against either Socket.io or SignalR or any other kinds of these frameworks, because you can use a much higher level kind of abstraction, a programming model that gives you the ability to basically make RPC calls to the client, or have the client make RPC calls to the server, so that it behaves like as if you're just making any call locally or to some kind of remote service. And that the framework itself does everything for you. So it also gives you the ability to hook into things like authentication. So now your call to the server can actually, but you actually know who the person is who's actually making that call. And as well, you can deal with connections as a whole. So if you wanted to say broadcast a certain message to everything that's connected to me right now, is one very simple call, and it'll just do it for you. You don't have to like keep track of all the connections and iterate through them and make sure they're not disconnected, send them down, and handle reconnects and all that stuff. A lot of these things are taken care of for you. You just talk to basically groups of connections. So you can say broadcast everybody, or you can put connections into arbitrary groups, and then send messages to an arbitrary group. So where this is useful is, for instance, if you want to say, send an alert to anyone who's like in Alberta or in Calgary, right? So so if you know that like where that connection is coming from, you can actually put them into a group called Alberta, and maybe even put them into a group called Calgary as well. So if you have a message that's only meant for people in Calgary, you send it to the Calgary group. And then behind the scenes, like SignalR, for example, will just take care of that for you. And you also target users as well, because it's hooked up to authentication. So if you want to send a specific message to all connections to that user, because the user can be connected to using multiple browsers, or they could be using other clients as well. But they're all under the same user. They will all receive that that message that you send them. And of course, you can still target a specific connection if that's what you wanted. And both Socket.io and SignalR support clients in multiple languages, so that so even though you're coding your server in either JavaScript or Asp.Net, on the client side, you can connect to it using things like JavaScript, C#, Java, things like that. So let's talk about Asp.NET Core SignalR specifically. So some of you said that you've used SignalR before, either in like the new SignalR, Asp.NET Core SignalR version, or the one before that, which we're calling Asp.NET SignalR. So it's, yeah, hopefully we'll come up with a better way to kind of distinguish them. But so yeah, so we have Asp.NET SignalR, which is the one that came out about 6 years ago, and now Asp.NET Core SignalR that came out a few months ago. So if anyone has done SignalR programming before, there's a main concept called hubs. And as the name kind of suggests, all the messages go through the hub. So a client will call a hub to kind of invoke things on the server. And the hub is also what's responsible for sending messages back to the client. And like I was saying before, you get clients in different languages. And you can deal with connections as a whole versus all different connections. With SignalR, Asp.NET Core SignalR is integrated really well into the Asp.NET kind of pipeline. So dependency injection, the routing, authentication, all that stuff more or less just works the way that you would use Asp.NET itself. And if anyone's used SignalR, Asp.NET SignalR before, you would have had to bring in jQuery as well, which was pretty cool back in like 2011, 2012. I think everyone was using jQuery at the time, so it made sense. But now it's kind of become a little bit of a burden that in order to use SignalR, you have to bring in jQuery. So with Asp.NET Core SignalR, you no longer have to have that dependency, which is great. But then another thing that we've done is that with Asp.NET SignalR, you would acquire the JavaScript library that you need to talk to it using NuGet, which is great for an Asp.NET application. But what we've kind of started doing is that we've kind of we're starting to follow the conventions of the client, of the language of the client that we're implementing. So for example, if we're building a JavaScript client, we're now putting that client on NPM because that's where JavaScript people expect it. Our Java client is going to be on Maven, and of course our NuGet, or sorry, our .NET client is on NuGet. So this does make it slightly harder for us to get started with Asp.NET Core SignalR in an Asp.NET application, because now you have to use NPM to pull things down. So hopefully we're at least somewhat comfortable with that right now, even though we may not like it. And you can also reference it off CDN as well, so you don't have to worry about kind of acquiring that file. So enough of me talking. We'll just kind of dive into some demos. And I'll just open up Visual Studio Code. Try to make it big enough. And once I have it open, once I open up something, actually, let me try something else. Open up my terminal. Actually, create a brand new project. So let's go to source. Go to demos, And I think I have a folder for Calgary. And we'll just call this SignalR demo because I don't know, I'm not creative. SignalR demo. So what I'm going to do is I'm just going to start off with a brand new .NET project. I'll use the .NET CLI to create a new .NET Core project, and I will create it with Razor pages, and also add it with individual authentication. We'll use that later. So it's going to go ahead and bootstrap my application for me. And now I'll open up VS Code. So some of you have a laptop open. I'm going to try this. I'm not sure if this is going to work. I will start a VS Live. Well, actually, I don't know if any of you have Visual Studio Code or basically like Visual Studio Live Share installed on your machine. Yep. All right, so we're going to try this out. I don't know how good or bad it's going to go, but we're going to try this. Just because I'm really curious how it works. So I'm going to go start a read-only session because I don't trust you people to actually see the read-only.
Got a whole lot.
Especially Sean over there. He's that's the only reason why he showed up. He's going to mess around. So because there's not an easy way for me to send it to you all people, I am going to open up a gist. Stay with me with this. It might be worth it. It might not. No, who knows? And I will actually go and edit this. I'm going to make you regret streaming this. Okay, so don't worry about writing down this GUID. I have a link. So go to aka.ms/Anthony live share. All right. You go there. You're just going to end up on this gist, right? And then just grab that URL and stick it into your live share. So for those of you who don't have it, just kind of humor me for a bit. I just really want to try this out. See how badly or how well this will go. So the idea is that, like, imagine if you're actually kind of giving a talk like this and everyone has their laptop open, they can actually see your workspace and not just what you're looking at. You can actually go browse around different files. And if my secrets file is there, you can actually browse around and copy my secrets. It's really fun. What's that? Oh, aka.ms/Anthony-live share. One word, LIV share. Is anyone in?
It's thinking, joining.
It's thinking? Actually, I'll see it here. Yeah, I don't see anyone joining. Come on. All right, I'm just going to, oh, Dave, first one in. Yes. Actually, I might have some prizes. But then I realized that you guys might already have some. Were you sent a box of these code magazines? Yes. Yeah, because I saw some in the lobby and stuff. All right, so that might not be a good prize. But I have to get rid of them anyway. I'm not dragging it back on the plane. Okay, so anyway, Dave's connected, so that's all that matters really, right? And so let's do some SignalR. So this is a regular Asp.Net application, right? Like there's nothing that we added to this. There's 3 people joined now. All right, so the first thing we're going to do is we're going to add this thing called the hub, because that's the most important part of our application. So I like to add it in a folder called hubs. You don't have to if you don't want to. I'm going to call this demo hub. It could be really anything you want it. I'm going to create a namespace. What do I call this? SignalR demo or something? Yeah. And then I'll create a class called demo hub. And it's nothing special. It's going to inherit from this thing called the hub. And I have to pull in the namespace. My VS Code is going slower. Why is that? Are you mining Bitcoins already? Like we talked about this before. It's like, can people start mining Bitcoins on my machine? So this is all it takes to create a hub. So now let's create a method on it that clients can call. So these are clients that could be like a JavaScript application that's running in the browser. Could be a mobile app. Especially if you're writing like Xamarin or Java or Android, you can pull in the Java SDK and connect to the SignalR hub. And it's just a plain old method that you need to create. So we can go public task, and we'll call this thing send. And it's just, I'm building a chat app. I didn't know you were streaming it. I told the team that I would never do another chat app demo. But then, well, this is the last time, maybe. So it's just going to take in a, like, what is it going to take in? It's going to take in a string called a message. Right, so far, it's just a regular .NET method, right? Nothing exciting. So now imagine if the JavaScript client, or basically any client that's connected, calls this method. What do I want to do? I want to relay that message back to all the other clients. So because I inherited from this thing called the hub, I have access to this client's property. And then in the client's property, you can see that I can address all the clients that are connected. I can only talk back to the caller if I wanted to. If I had added people to or connections to groups, I can address a certain group. I can address all the groups except for a certain group. So there's all sorts of stuff you can do to really, specify where you want your messages to go. I'm just gonna address it to everybody, and then we're just gonna call send async on it. And we're gonna call. So the first thing that we have to provide is a name of a method to invoke on the client. So in this case, I'm just going to call this thing called new message. And then and then after that, you're passing in parameters to this method. So the first parameter I want it to be the sender's name. Right now is anonymous. And the idea is that we're going to add authentication later, and we're actually going to see the name of the user that's actually sending the message. We're just going to call it anonymous for now, and we're going to send the message. All right, so we're going to invoke this thing called new message, and with the user's name and the message itself. And it's still complaining because I have to return the task. But now that's it. So that's the whole hub. So now we have to wire it up to our application. So the way Asp.NET Core works is that a lot of these things now are opt-in. So out of the box, you won't get SignalR until you add it. So we're gonna go ahead and add it here. Is this big enough? Like, should I make this bigger? Okay. I'll try to make it one bigger. I'll hide that. How's the live share going?
Good.
Like,
Yeah, I'm following
give
on.
up? Cool. So first thing we're gonna do is we're gonna go into our configure or our services, and we're gonna add SignalR. Pretty simple. So that adds all the middleware, or basically all the services that that SignalR requires. So so that later on, when SignalR needs to access these services to actually make SignalR work, they'll be there. The next thing we do is down in configure, we'll add SignalR. And this thing takes a builder. No, it's use SignalR. And all we're going to do is we're going to say, we're going to map a hub. And the hub is the one we just created. It was called demo hub. And we're going to give it a route. So I'm going to just put this on /demo. Now my application has been configured with the SignalR hub, and it's actually been activated. So the last thing I have to do is actually write some JavaScript to actually talk to this. So let's open up the index file. I hope it still works. It looks like I created an ASP.NET 2.2 preview application. A little bit worried about that, but we'll see. This might work. I hope so. So the first thing we're going to do is we have to reference the script. So we can either use npm to pull it down, or I'll just copy it from somewhere. So I have hopefully it just created already. Here it is. and I want to take this tag. So all I'm doing is I'm just pasting in a script tag to a CDN. That's going to pull down the JavaScript client for SignalR, and I'm going to write some script. I'm going to write some JavaScript. So the client is fairly easy to use. First thing you're going to do is you have to create a connection, and the connection is a new SignalR .hub connection builder. And then you want to call this with a URL. And the URL is /demo, because that's what we called it. And then lastly, we just want to build it. So now we have a connection. The connection is not started yet. So we can go ahead and we can go connection.start. But before we can do anything, right now it's going to connect. Like right now, all this is going to do is going to make a connection, but we're not listening for any method calls or events. So we're going to go connection.on and listen for the event. And I think we call our event new message. And then that's going to take a sender and a message. Oops. And all we're going to do right now is just going to go console log. We'll console log out the sender and the message. We'll make a real UI for it later. So now we have the connection to the server as well as something listening for a method invocation. So hopefully this is going to work. So apparently I can also share my connection. I haven't tried this, so we're not going to do it. But so apparently anyone who's connected can browse to my website from your machine if it's actually working properly. I'm not sure if it is, so I'm not going to try it.
2 minutes.
So we're going to open it up. So because we don't have a UI, we're going to use the console. So we can see that we've made a WebSocket connection to the browser or to the server. And then in here, we can now make a call on the connection. So I'm just basically just typing this random JavaScript here, treating it almost like a REPL. And we're going to go and we're going to send. So we're trying to invoke that send method on the server. So the method name is send. And then we're going to send it a message. So I'll be like, hey. So what should happen is that this thing is going to call back to the server. And actually, oh no, what have I done? Oh, I just lost my thing. Connection.send, send, hey, and I'll press the right key to get out of my zoom. I'm actually going to go back and set a breakpoint right here. And we're going to hit that. Didn't hit a breakpoint. What happened? Well, but something happened because we actually got the message back. So I have no idea why the breakpoint wasn't hit. This is new to me. We'll try again. It's probably not going to hit it. Oh, now it did. So now I hit the breakpoint. And you can see the message and all that stuff, right? So this is just standard, like just JavaScript invoking something in C# that's now invoking something back in JavaScript. Not very exciting, but at least you can see that it's working. If we actually browse over the network, I'll reload this. We can see that we have a WebSocket connection. Make this bigger as well. So all it said was like, I speak JSON. Can you speak JSON? And now the server is like, yeah, let's go. So now let's see what happens when we send a message. Look at that. Now, if we actually look back at the network, you can see that the server has not only, so the green one is my message back up to the server, basically invoking send with the string hey, and then on the way down, it's invoking a method called new message with the arguments of anonymous and hey. So it's all working, and it's not a ton of magic there. It's basically just putting a couple of layers of abstraction over top of WebSockets. So now, what we're going to do is we'll actually kind of put a proper UI on this so that it looks a little bit better. So I'm going to delete my code, go back to my gist. And paste that in. I'm going to save it. I'll run it again. And hopefully, I'll have the app actually up and working. So now I should be able to type a message, hey, and you can see that now it's talked back to the server, and then it's posted on my screen. And I can open up another browser just to make sure this actually really is working. Go. You can see that shows up on both browsers. So that's how easy it is to set up your application for real-time web. Back to slides. I forgot what I was going to talk about. You can also have a .NET client. I'm not really going to show you. Actually, I'll show you the code, but I'm not actually going to run it. So what we just saw was JavaScript, but you can do the exact same thing in .NET and in Java as well. So we'll fire up a console app with really big fonts. And yeah, it's actually hooked up to a different API. But you can see that the code here, if you like squint, it actually looks just like the JavaScript, except with camel case and maybe like different quotes and stuff. But it's pretty much the same code, but in .NET now. All right, so I'll go over just some quick changes from Asp.NET SignalR in case anyone's planning on moving from Asp.NET SignalR to Asp.NET Core SignalR. So it's a brand new protocol, so you can't use the old library to talk to the new server. So your clients have to match the server. So if you're using Asp.NET SignalR, you have to make sure that they use one of the older clients. Although we're still working on the new client, on that client actually, we're still releasing updates, and we're actually going to try to make the protocols almost working together, but not quite. Before it would do auto reconnects for you. So so WebSockets and server-side events, basically the web in general is a little bit flaky. So sometimes your clients just get disconnected, especially if you're on a mobile phone or something like that. So before we would actually automatically implement auto reconnect for you and actually replay any messages that you might have missed. That actually caused a lot of bugs in the server. It was really hard to debug, memory leaks everywhere. So we decided not to support that anymore. It's still really easy to reconnect from a client. You literally just call start again. So you have to listen to the disconnect event and then do your kind of back off logic or kind of like timeout logic. And then just basically call start again, and then you'll be reconnected. So that's not too bad, but the message replay is a little bit more harder to solve. Hopefully not too many people relied on that before, but that's not there right now. I'm not sure if there's any plans to add it back. There's a thing called hub state that I don't think anyone really used. That's gone now. Before you can connect to a single endpoint from the client and have access to multiple hubs, now you have to make a connection to for every hub that you want to connect to. That's usually not a big deal because most apps, or at least most pages you go to, or basically most parts of a site or an app that you go to, typically would be one hub, right? So you might have a hub for, so for instance, like your homepage feed, and then you might have a hub for like a chat, but depending on which page you're on, you just connect to the right hub. So that's typically not a big deal that we don't have these the hub multiplexing that we used to have. We might bring that back, but right now it's not there. And before the JavaScript was able to reference this piece of server-generated JavaScript that basically looked at what methods were available on the server and kind of stubbed out some calls, like some methods on the JavaScript side. So you can actually go, instead of going like, connection.send and then a string for the method name, you can actually go connection dot and then the method name on the server and call it. That's not there right now. Like I don't, to be honest, I don't miss it too much, but it might come back one day. And before, we had different ways to scale out. It's really just one, like you just more or less plug in this thing called a backplane, and it will just work. And we supported Redis, Service Bus, as well as SQL Server. And the reason you need a backplane is because imagine you have your SignalR running on one instance. Like, so you deploy your app to one instance of a server or an app service. It might be or it could be a container somewhere on the web. That's cool, right? So every connection is connected to the same instance. But imagine now that you scaled out your app, you got multiple copies of the app, and one of these instances wants to send a message to everybody. It only knows about the connections that it's connected to, but it has no idea that the other kind of instances even exist. So basically, only part of your users will get these messages. So to solve that, both Socket.io and SignalR and these other frameworks have these things called a backplane, which is basically a communication mechanism that these different instances can talk to each other on. So that when you actually when you say on one instance, I want to send a message to all connected users, it will send it to all its connections, but it'll also let the other instances know to send that same message to everybody as well. So before we had a basically like a one size fits all kind of way of scaling out. We no longer really have that, although we still have it. We still support Redis, but we have a new kind of Azure service that does this a lot better that we'll talk about in a little bit. And also another big change is that before SignalR allowed you to, say you have multiple instances deployed, when you lost a connection, you can actually go and the client can actually just go and connect to any other random server, and it'll still work. But now we require sticky sessions. This is not really that big of a deal because you're still fine with WebSockets, but it's really the other protocols that you have to worry about having sticky sessions. So especially long polling, because when it kind of sets up that new request again after it receives a message, it needs to go back to that same server. So that's just something else you have to worry about. But there are some new features. It still supports JSON as a messaging format, but it also supports this thing called message pack out of the box, and it's a binary protocol, so it's a lot more efficient. So what you'll find is that SignalR, Asp.Net Core SignalR is a lot faster, or can be a lot faster because you can switch to a binary protocol, as well as like the way that it does scale out using Redis or the service. It's a lot more efficient than it was before. Also, you can now do streaming results. So when you make a call to a server, you can now return this thing called a channel. That's a new type in .NET. So it's not just one result. You can actually hang on to this channel and keep pumping data down that channel, and the caller will keep receiving those messages. I think it's a kind of a niche case, a niche use case, but it's kind of cool that it's there. And it's also plugged in really nicely with Asp.Net Core authentication or authorization, as well as dependency injection. I'm actually not gonna demo this because it might take a little while. But so far, what we've seen is basically everything talking through the hub, right? So in order for a message to be sent, you need to talk to the hub. So right now, it's a client talking to the hub, and then the hub talking back to the client. But what if you had something in your Asp.Net application? So for instance, say you set up just a regular web API endpoint, right, that someone can call. So it's outside of SignalR, like it knows something about SignalR. So when you call that, you still want to broadcast a message out to, to people connected over SignalR. Before, what you had to do is you had to kind of use this thing called a global host and stuff that kind of came with ASP.NET SignalR to kind of dig out the hub itself, and then you can call .clients.all.send on it. But now we have SignalR ASP.NET Core SignalR is now fully participating in the new dependency injection framework that's in ASP.NET Core. So you can just ask ASP.NET Core for an instance of this thing called an iHub context, and then the T is the type of your hub. And what you're going to get in your controllers, for example, when you ask for that, is you'll get that context, and you can invoke .clients.all or whatever you want to send these messages straight from there. It's really quite nice. Before, it was pretty tedious to do something like that. What else was I going to talk about? Authentication. So we can show this. So far, like everything's been anonymous in our application. So this is the wrong application. This is the one. Okay. So we go back to our hub. It's a hub that anyone can connect to. But sometimes you want to lock it down to certain people, right? So in ASP.NET Core or even ASP.NET, typically the way you lock things down is by applying an authorized attribute, and that's what will work here as well. So you can apply authorize to bring that in. But now, if I've done everything correctly, when I run this, my app actually won't work. And I'll be really surprised if it works. So we can see that we got a 401 error. All right, so let's make this work. So we actually don't need to worry about, we actually don't have to change anything on the server to make this work. We can actually just go ahead and register ourselves. Let's put in my Microsoft email, my really secret password. New. So now I'm logged in. So you can see that I'm logged in. And I kind of look at my console, everything's good again, right? So, so just by adding that one line of code, I've locked down my hub to just authorized users or authenticated users. So it's really useful. And you can also use the other ways that you can authorize connections in ASP.NET Core. So you can actually, specify policies and stuff, and it should all work. So now let's make use of the user's identity. So we'll close that. So right now here, we are just saying everyone's anonymous, but we actually have the user ID now. And we can take that out of the context, which is also part of this hub thing here. So we go context.identity or something, or not, .user.identity, is their name, .name. So now instead of anonymous, we're going to send that. I'm going to save it. We'll run it again. I should still be logged in here. Wait for the new one to fire up. And there it is. I'm still logged in. But now when I say hey, you can see that like I have my identity there. And I can open up another one, do the same thing. I'll register myself here as well. And I'm logged in. And now when I say hey, like it's using my identity to talk to talk to the connection and talk to the hub. So I think that's all I wanted to show. So it's really easy to hook SignalR into your existing ASP.NET application or authentication authorization. Oh, maybe you want to see a non-chat demo. I have one that should work. So a couple of nights ago, I was playing with this app that I have that uses SignalR. and I've deployed it to Azure Kubernetes Service, AKS. I need to get services. So I'm just going to talk to my AKS cluster to find the services that I have. All I really want is my external IP. So if I go to this IP, what I have here is I have two .NET applications. So I have a front end that is Asp.NET Core. It's got SignalR in it, and it's connected to the browser. So that's what's serving back this page. And then in another container in Kubernetes, I have a .NET application that's got a TensorFlow model in it that is not very good at identifying fruit. I trained it myself, that's why. And I'm so bad at it that like I actually had to pick 3 really, really different fruits. Look at that. You can't even tell. So like I literally tried to train it with like apples and oranges, and everything was an apple. So if you're wondering why I only support bananas, grapes, and apples, it's because they're like totally different shapes, and they have a slightly higher chance of succeeding. And I think some of the images that I kind of stole before have been removed off the internet, so they're not working anymore. But anyway, it mostly works, right? If you just ignore the fact that the results are wrong. So what the workers are, like the workers are just like, this app just keeps pulling images randomly and tries to figure out what it is. And then it sends an HTTP request to my ASP.NET front end. And then it relays, and ASP.NET relays the result to my browser using SignalR, right? And I was like, well, wouldn't it be cool if I just scaled up the workers? We now have 1 worker, right? It's going pretty slowly. It actually goes pretty fast, but to make this like really kind of dramatic, I had to put like a 1-second delay in it. It's called a demo, people. But the idea is what matters. So I'm actually going to go, and I have to remember how to do this. I'm going to try to scale this. And I actually don't even know how to use scale, so let me look it up. It's replicas, okay. So I'm going to go scale -- replicas equals, let's go 100. And then I think this thing is called image classifier worker. Maybe? Nope, maybe not. Oh yeah, it's a deployment. Is that going to work? All right, so now I'm scaling out to 100 containers running my worker. So within about a minute or so, it should speed up. So like in a sense, this has nothing to do with SignalR anymore. I'm just kind of showing you something cool. So I'm using this thing called, it's something that we just announced at Ignite called virtual nodes in Kubernetes. So I don't know how many of you all kind of done Kubernetes or Service Fabric, right? But typically you set up a cluster, with machines, right? And you pay for these machines all the time, just sitting there. And then when you schedule a workload on it, so say send up like the web front end on a worker, it'll place that workload on your machine. But if you have nothing running, or if you all of a sudden you need 100 of these things running, the best you can do is go run around and scale out your machines. You can do it. You can use auto scale to scale this out, but it still takes a while to scale out the machines before you can place the workload on it. And what virtual nodes does is that instead of scheduling your workload on the nodes in your cluster, and I'm talking really slow because I'm trying to stall until this thing works. But what virtual nodes does is that it will schedule your work out to Azure Container Instances, which is kind of like our serverless containers offering. And so because there's no machines to provision, if you want 100 containers running, let's just give you 100 containers, no problem. And now I've stalled long enough that I'm a little worried now. But anyway, if it doesn't work, it doesn't matter because, like I said, it's just got a little bit of SignalR in it. Let's go cube. Get pods. You can see they're all kind of creating. They're working really hard, but it's close. There should be another one running now. So yeah, you got 2 workers. And then if we check back, like, in maybe 3 or 4 minutes, we should be up to 100, and this thing should be just flying off the screen. But that's one use of SignalR that's not a chat. I'm required to show you that because SignalR is not just for chats. All right, back to my slides, which is really just my prompts for what to talk about next. So we have about like 20 minutes or so. What I want to talk about now is this thing called, well, basically like how would you scale out a SignalR application, right? Before, like I was saying, the only choice that we have was to stand up our own backplane, basically standing up our own instance of Redis. There's probably not just one instance, because we want it to be highly available. So basically make sure that you stand up a cluster. Same thing with if you want to use SQL Server or if you want to use Service Bus. You kind of have to kind of stand those things up yourself and then connect your SignalR applications to it so that it can act as your backplane. But now we have a new service in Azure called Azure SignalR Service. And we announced that it was generally available at Ignite a month ago. So you can now use it for your production workloads. And it will take care of all the scaling for you. I'll kind of talk a little bit more about it first, and I'll kind of show you in a diagram how it works. So you can offload your SignalR connections to the service instead of running that in your Asp.NET application. There's a free tier. I believe you can have up to 5 of these things. So if you're just writing chat apps with like 20 of your friends, you can set up one of these. You get 20 connections. But you can also pay for these things called units. And each unit is about $25, I think, and you get 1,000 connections. And you can have up to 100,000 connections right now. We're hoping to go even higher than that. And all it takes to add it to your Asp.NET Core application is basically adding a NuGet package and a couple lines of code. Oh, okay. I guess I'm going to create an instance. So let's go here. So it's really easy to create an instance. Go into Azure, search for SignalR. And there it is, SignalR service. Go create. And then we're going to go Calgary.net. And I'll just stick it into a new resource group called Calgary.net. Create that. We'll put it closer to us. And I've already used up my 5 free. So I'm going to, well, Microsoft's going to buy me the standard one. And down here, you can actually move the slider around to change the number of units. I'm just going to leave it at 1. So that gives me 1,000 connections. So unless we have like 975 people watching online right now, it should be OK. So that's going to go off and create. Let's talk more. So here's the diagram. So right now, this, like, if you use SignalR by itself, here's kind of how it works, right? You have all your clients. Both the web traffic and SignalR traffic will go to your Asp.NET Core application. But with the SignalR service, what happens is that the SignalR traffic goes to the service itself. And there is a WebSocket connection, or there's actually a few of them, between the service and the server. But the server manages all the client connections, which is really the bulk of the work for your Asp.NET Core application. That's what takes up the most memory. That's what takes up the most CPU when you have to send out messages. So not all of that is uploaded to the service. And the only time that the server and the service will talk is when you want to send a message. Then all the Asp.NET Core server will do is tell the service, hey, I want to send a message to this group. And then the server does all the work. And likewise, if you have a client invoking something in a hub, the service will send that one method invocation to the hub. The hub will do work, and then it may or may not tell the server to do more stuff. Right? So now the hub becomes basically like the Asp.NET Core server becomes super lightweight. It's not doing a lot of work. All the stuff that was doing before to deal with the clients and the connections are now offloaded to the service. So the good part of this is quite often in an application that has both web traffic and SignalR traffic, you need to scale those separately. So So maybe you're implementing an app that is actually quite simple, and all you may be serving is like some HTML, but you have to scale it out to a lot because you have to handle a lot of SignalR connections. Now you can actually scale those out separately. Likewise, the other way around, maybe you only have a few SignalR connections, but you have like a really busy API, right? So you can scale this thing out a lot, but the service can stay at like 1 unit or something like that. So now you really have this choice. And there's other benefits as well. For instance, if you start putting something in front of your Asp.NET Core app that might not support WebSockets, the one thing that comes to mind right now, and I think that's a point in time thing right now, is a new service called Azure Front Door that kind of like acts as like this globally distributed proxy that makes it really easy and efficient to set up. To basically set up a proxy really close to your clients, wherever they are around the world, so that your app works a lot faster. It's kind of like a CDN, but not quite. It's kind of like traffic managers, but not quite. But I won't get into that here. But what I will get into is that a service like that right now doesn't work that well with WebSockets. So if you were to keep all your SignalR traffic in here, you won't be able to put something like Front Door in front of it. But with the service, you can. So basically, you would have a proxy in front of the SignalR, or sort of the Asp.NET Core application that might not handle WebSockets that well. But because there's no WebSockets now between the client and this app, it's fine. And then when the client connects to here wanting to talk to SignalR, all this is going to do is basically return give a response that says, hey, redirect over there. So the actual WebSocket connection is between the client and the SignalR service. So you kind of have the best of both worlds. You can basically use all sorts of proxies and all sorts of different things with your main application, but still have the clients talk full WebSockets to SignalR service. All right, so now that's hopefully I've stalled enough for this service to have been created. It has not been created. This is a first. One moment. Usually it's about 2 minutes, so we'll see what happened. Maybe it's there. Maybe the SignalR connection that gives me that that notification wasn't working. It looks like it's kind of there. We'll see how it goes. So the only thing that you need is a key. This thing is really simple, not too much going on. So I'm just going to go ahead and copy this key. And then I will. Oh, and meanwhile, we're up to 88 workers or something. Yeah, so it's not just like ripping by. But we'll let that go. So now we're going to go back to our app, and we're going to add the service to it. And to add it is really simple. So the first thing we have to do is, remember I said it was one NuGet package and a couple of lines of code. So we're going to add the NuGet package first. We're going to go with .NET add package. I believe it's Microsoft.Azure.SignalR. If it doesn't work, we're going to Bing or Google it. Let's see. Okay, it's working. So that's going to add our reference to the package to talk to SignalR service. And now we have to make two changes. So the first change is, right now in our startup, we're calling add SignalR. We just have to change that to add Azure SignalR. And it takes a connection string. So we're going to paste in a connection string. Hopefully it's working. Why is it upset? Why are you upset? Uh-oh. What I'm worried about is that because I'm in an Asp.NET Core 2 application, or the 2.2 application, this may not be the right package anymore. One sec, let's see what's going on. I am in a 2.2. Yeah, like I brought in some 2.2 stuff in here, so it might not quite work. So hopefully I have a backup. Let's see. Chat 2. Let's see if this one works. We'll do the same thing to here. If not, you're just gonna have to trust me if this thing works. .NET add package Microsoft .azure .signalR. And then we're going to do restore. Then once that's been restored, now let's see if it's there. I really hope it's there. Uh-oh. We're going to build this. Oh, I'm a liar. I'm very curious what's happened now. One sec. I have a feeling I added the wrong package. NuGet. And I watched a presentation. Somebody did this like 3 weeks ago, and they had the exact same problem. And we don't learn. They're like, whatever, it's fine. I'm sure it won't happen to me. It's only for that sucker. Haha. No, it's a lie. So I have no idea why this doesn't work. Sorry? I think I do. Because it is the Azure SignalR service. When you're stuck, what you do is you go to docs.microsoft.com. All right, one last try. This is very embarrassing. Did you stop the camera from rolling? This is gonna get cut out, right?
Yeah.
How many people are watching?
4. 400.
4?
Yeah. 3.
So 4 people online. 3 now. So like, yeah. So people are dropping off in real time. So this is fantastic.
I have one more.
Oh yeah. Oh, there's 2 people streaming. I don't think that's been authorized. I don't know what's going on here. Yeah, I'm adding the right thing. Well, I'm just gonna go ahead and give up. But if I were able to do this, it would have been so amazing. I don't know what to do now, because that was my my big finale outside of this fruit thing. It's now up to like 90-something workers. Should be 100. Like, I think it's kind of breaking Chrome right now. I don't know what's happening. All right, so we'll let that demo fail be erased off the internet.
Mm-hmm.
And then we'll move on. So so last thing I want to talk about is what if you don't want ASP.NET at all? We're at a .NET meetup. I mean, who would want to do that, right? But there are people that want to enable WebSockets with like in other languages and integrate WebSockets with other Azure services. So, for example, Event Grid or queues or stuff like that. You want those things to trigger WebSocket messages to be sent. What do we do? Well, we have a service now that basically all it does is work with WebSockets. Let's connect them together. So what's a technology in Azure that's really good at connecting services and languages with other Azure services? And that's functions. So we've created a SignalR service binding for functions. So really easily, you can add the ability to send messages from Azure Functions to Azure SignalR service without you doing really any work. Like, so I don't know if, like, who's used Azure Functions before? So a few people. So one of the really cool things with Azure Functions is this concept called bindings. So if you imagine in an application, you want to read something from a database, typically what you do is you have to new up the client for the database, make the call, and you get the data back. And same thing with writing a database. You have to new up the client, do some stuff, write the data back. Right? A lot of code, just so you can write some code to a database, for example, or to read from it. And Functions has this thing called bindings that allows you to declaratively say, I want to write some stuff to this database over here, like Cosmos DB, table storage, some other stuff. And bindings allows you to, and then in the application, all you're working with are objects and strings. And in the case of an output binding, you just return a bunch of objects. And behind the scenes, Functions will actually write those to the right places that you told it to. So your code becomes very clean. Your first line of code, you already have the objects you want to work on. You do some work on it, and you return it. And then it gets written to the right place. So SignalR becomes another output binding. So when you return a bunch of objects, it will get basically sent down to SignalR service to be sent off to a bunch of clients. So I was going to do a quick demo, but seeing my luck so far, I'm not sure if that's really such a great idea. But I will just do one that hopefully has been already set up and works. All right. So this is a function application. It's running locally. And guess what? It's a chat app. So it happens to be JavaScript. It doesn't really matter, to be honest. It's very simple. It has an HTTP endpoint for clients to call to create a message, basically to send a message. And it's really simple. It's an HTTP endpoint. It happens to write that message using an output trigger to Cosmos DB. We don't have to worry about that. But it also pulls in this thing called an output binding for SignalR service. And all we're saying is that when something is sent to this output binding, please send it to the SignalR service. That's been kind of configured in my settings. So my settings, I've kind of configured my connection string. And I'm saying, please send it to a hub named chat. That's it. And then my JavaScript is really, really simple. So the first line of JavaScript, I'm saving the body of the request. And you shouldn't do this in a production app, but this is a demo. I'm literally taking the request and I'm saving this into Cosmos DB. That's the first line. And then the next couple of lines here is me taking that message body and sending that to SignalR service to be passed off to the SignalR connections. And it's invoking the new message method on the clients. So I'm just going to go ahead and run this. And while this is running, I'll also start up the UI for it. And here's the UI. This one's lower security. It's just asking for my name and it just takes it. But it's all good. So if I refresh this page, put in my name again, we can see that it's talking to our Azure function to get the information that it needs to talk to SignalR. It's talking to the SignalR hub. And then it's also calling some other Azure functions to pull back my message history. But now when I send a message, and I think I can put a breakpoint here as well, although with my luck, who knows at this point. Nope. Maybe breakpoints. Oh, actually, no, the breakpoint's not working right now. But you can see that it's doing the exact same thing as before. And if I reload it, it's actually being saved on the server because it's using the Cosmos DB output binding. All right, so now you can serverlessly, without any Asp.NET, with just a couple lines of code, we can connect to SignalR service and also send messages to it using just functions itself. So I'm going to end this with hopefully a better demo again, not a chat. So I built another one called the flight map. It's kind of like a knockoff of that thing I showed you earlier, except it's not pulling down the font, which is kind of sad. There it is, this font. Look, the plane's moving around. So what I have behind the scenes is this thing called a durable function, which is it's a type of Azure function that you can tell to run for longer than a few seconds. In this case, it's actually running over and over and over again until my Azure credits run out. And what it's doing is it's actually just pulling back some historical flight data and playing it back at like 10 times speed. It's like, I don't know how many you fly a plane, like one of you, like you do, or at least you work in the airlines.
Yeah, I work in aviation.
So planes don't go this fast, but for added effect, I made it go really fast. But yeah, so like all it's doing is that it's a very simple function, and we're using an output binding to broadcast the location of actually a lot of planes. Like it's not just a few planes, right? It's a lot of planes. I set this up for Ignite, so that's why it's kind of based around Florida. But yeah, so this is an actual application that's using SignalR service, and there's a whole bunch of other ones as well. But won't bore you with that. We're gonna see how we're doing with this thing. That like my computer's getting really hot right now. But you can see that it's going so fast now you can't even see the fruit coming up. But we'll wrap up, and then I'm gonna go home and I'm gonna like figure out what's wrong with that thing, and I'll be like, of course. I got it all wrong. So here's some resources. I've kind of created this little aka.ms/yyc SignalR short link. And I just have a few kind of links in there to some documentation. A Code Magazine article. I have a bunch of hard copies here if anyone wants it. Like I heard that you all kind of already got these. Please take them. I don't want to take them back. I have some stickers up here too. And then check out a bunch of documentations. We now have quite a bit of video content on SignalR and SignalR service on Channel 9 as well. Check that out. I think that's it. Yeah, thanks for coming. And sorry about the demo. So I'm just gonna stick around. My flight's not till 11. If anyone wants to go grab some food or whatever, let me know.
We had one question for you from somebody that was watching the stream.
Oh yeah?
So the question was for the authentication, does that also work with like when you're using login using Google or Facebook?
As far as I know, it does, because it just uses the same pipeline. So at that point, it's just a thread principal, and it doesn't even know where it came from. Yeah, please. I got some.